Hello, geometry. Here we go with lesson number 5. It's our second to last lesson. Areas of regular polygons, number 1. Guess what the last lesson might be. So this one's going to have a lot of vocab that is essential for understanding this. So I'm going to try and make it so that you can see the whole thing at once. It's too small. I think that's probably good. All right. So the figure above is a regular hexagon. Nothing crazy there. Since it is a regular polygon, all of its sides all of its sides are congruent and all of its angles are congruent. So it makes it regular. Okay. So the middle of the polygon is called the center. That one's not too hard to remember, but you should know it. Each of the blue dotted lines represents a radius. This is your first vocab word that I really need you to know. What does a radius do? It's the distance from the center of the polygon to a vertex. Hopefully you know what a vertex is by now, but a corner of the hexagon. So a radius connects center to vertex. The red dotted line is called the apothem. This is a new word. I always think of it sounding like a possum with a lisp. So apothem. What this does is it connects the center to the this is a segment from the center that is perpendicular to a side. So in reality, it's the distance from the center to the side. All right. Notice what one apothem and one radius form. You see it up here. The apothem and one radius form a right triangle. We are going to use that in a little bit. All right. Before I do anything else, I'm going to continue talking about some of the vocab. In the figure above, angle 7 is a central angle. What makes it a central angle? The fact that the vertex is at the center and it is formed by two radii. A central angle is formed by two radii, not like 8. 8 is not a central angle, 7 is. Even though 8's vertex is on the center, it's not a central angle because it's formed by the apothem and the radius. How many central angles are there in a hexagon? Well, if you look at that there are 6 of them. Let's say we had an octagon. How many would there be then? There would be 8. If all of the central angles come together at a point, which they do, they all come together at the center. What do they add up to? Well, if they all add up to the center, which is a circle, how many degrees in a circle? 360. So in a hexagon, like we're dealing with here, what is the measure of one central angle? Well, the whole thing's 360. There's 6 of them. Divide and you get 60. What about an octagon? Well, there would be 8. So 360 divided by 8 gives me 45. Okay. Now, what does the apothem do? The apothem cuts each central angle in half. So what is the measure of angle 8? Which is the next part in the notes, which I can't see right now, but you can. Half of 60 would give me 30. So the measure of angle 8 is 30. So I'm going to clear all this and we're going to go down and do a practice problem. Find the area of this whole hexagon. Well, watch how I do this. So I see I've got a triangle right here. I'm going to find the area of that triangle, which is 1/2 base times height. Well, the base I've already given you, it's 10. The height is that red line, or we call it the apothem. We don't know what that is yet. Well, we're going to use what we just figured out to solve for the height? Well, what do I know? Well, I know that this is 5. That apothem cuts that side in half. Okay. I need an angle though. I can't figure out any other side without an angle. Well, that's where that we just talked about comes into play. Each central angle up here is 60, right? The apothem cuts that in half, so this is actually a 30-degree angle. Now that opens up the 30, 60, 90 relationships. The opposite the short leg is 5, or the opposite, the short angle is 5. So the short leg is 5. The hypotenuse is 10, which I don't need here, but I'm going to put it. And then the height is 5 radical 3. Well, the height is the apothem, but that's what we needed here. Now I've got my base and my height. Let's find the area of that triangle. So 10 times 5 gives me 50 radical 3, and then I want half of that. So that's 25 radical 3. That's the area of that one triangle. But it's a regular polygon, so all of those triangles are the same. There's 6 of them, right? So I'm going to multiply by 6, which gives me the area of the whole thing, which is 150 radical 3 centimeters squared. Okay. Some of you might like that method for solving it, and you might actually resort to that. That's fine, but I want to show you a cool little relationship that happens on the backside here. So I want you to notice from what we just did, how many congruent triangles are there in a regular hexagon? Well, there's 6. If we find the area of one of those triangles, we can multiply that number by the number of triangles to find the area of the polygon. Is there an easier way? Yes, there is. So the area of one triangle is 1/2 AS. Now, I know it's base and height, so I'm going to lay out what this was. A was the apothem, which in a triangle was the height, and S was a side length, which was our base, right? So then we just multiplied it by 6 to get the area. I'm going to recombine that multiplication. So I've got 1/2 times A times S times 6. I'm going to recombine that to 1/2 A, but I'm going to lump 6 and S together. So 6 times S, where S is a side length. What does 6S represent? Well, if it's a hexagon, 6 times S gives me the perimeter. Now you might be thinking, well, what happens if we have a different shape? Does it still work? Well, yes, because we would not multiply by 6 then. If it was an octagon, we'd multiply by 8, and then you would have 8S, which would be the perimeter of an octagon. So what does this help us with? We can find the area of a polygon, regular polygon, and that's important. If it's a polygon, this doesn't work. It's just a polygon. But if it's a regular polygon, we can do 1/2 times the apothem times the perimeter. And that is what you will find on your formula sheet. That is the area of a regular polygon formula, is 1/2 AP. Okay, now we're going to use that on the next 3 problems. First one is an equilateral triangle. The fact that it's equilateral means that it is also equiangular, so it is regular. It's important to understand that this only works for a regular polygon. So 1/2 AP. Once I find the area, the apothem and the perimeter, I'm good to go. Now, it's not going to be super easy here necessarily. Sometimes it is, sometimes it isn't. What I gave you was that all 3 sides are 20. I can find the perimeter hopefully pretty easily. 20 plus 20 plus 20 is 60. The apothem, though, is not so easy. There's my center. I'm going to draw in with dotted lines my radii. I'm just going to do 2. I guess I could do all 3 of them. Doesn't really matter. The apothem change color so you can see it, is that blue line there. So let's figure out this triangle. So I'm going to redraw that triangle. Okay. And what do I know in that? Well, the apothem cut that 20 in half, so this is 10. I don't have an angle yet, but I need an angle. This is where those central angles come in. Well, it's 360 divided by how many central angles there are. Well, in an equilateral triangle, there's 3. So 360 divided by 3 is 120. The apothem cuts that in half. So it's 60. So this is 60. The central angle here is 60, which leaves me, this is 30. And my apothem is here. So I need that. That's the short leg in this case. In the previous problem, the first practice problem on the front, the apothem was the long leg. This time it's the short leg. It's not always going to be the same. Right? So how do I find that? Right now I've got the long leg. So long leg equals the square root of 3 times the short leg. So A here. So 10 equals the square root of 3 times A. And we get the radical on the bottom again. So it's going to be 10 radical 3 over 3 is my apothem. Now, if you're not keeping track of what you need and where you're at, you can get very lost on these problems. As soon as I found the apothem, I wrote it in here. And I see that I've got both pieces now. Once you have both pieces, you can move to the formula and finish up the problem. So 1/2 10 radical 3 divided by 3 times 60. Now what I'm going to do is I'm going to combine my 1/2 and my 60 first. Half of 60 is 30 times 10 radical 3 divided by 3. So I've kind of recombined things to make it a little easier for me. 300 times 10 is 300 radical 3 divided by 3, and then 300 divided by 3 is 100 radical 3 meters squared. And that is the area of that equilateral triangle. Are there other ways you could have found that? Yes, but I'm trying to use this formula as much as possible in these notes. Okay. Same thing goes for the next one, which is a square. It is a square because all 4 sides are the same, and I have a right angle, which means all the angles are going to be right angles. I could go into Y, but we don't need to at this point. So 1/2 AP. I did not give you either one of the apothem or the perimeter here. What I gave you was a radius. It's 16 centimeters. All right, I'm going to draw on another radius real quick. And I'll draw on another one. And another one. All right, I'm going to go ahead and draw my, you're going to notice that I do this a lot. I'm going to draw in my triangle, which I should also draw in my apothem here. So I'm drawing that triangle there. This is 16. This is my apothem. This, I always call it Y. All right, because Y is not a side length. So I don't want to call it P. X, I like to use X for my whole side length here. Okay. So I use Y. Y is half the side length. Okay. So 1/2 of X is Y. Now, we need an angle, right? So 360 divided by the number of central angles, which is 4, gives me 90. All right, so 90 is the central angle. But then the apothem cuts it in half, so this is a 45. So I've got a 45 here, which means I've got a 45 here, and I've got a 45, 45, 90. These are equal. In this situation, this is equal. So my hypotenuse is equal to the square root of 2 times the leg. So 16 equals the square root of 2 times the leg. divide by square root of 2. 16 square root of 2 over 2, which reduces to 8 radical 2. That is my apothem. So my apothem is 8 radical 2. But it's also x. Or sorry, y. So 8 radical 2 equals 1/2 of x. So what do? I need to double that now to get a side length. So x equals 16 radical 2. That's a side length. What do I do to that to get the perimeter? You got to multiply it by 4 because there's 4 sides. So 16 radical 2 times 4 is 64 radical 2. Okay. Now I've got both pieces. Now I'm going to go ahead and go into the formula. 8 radical 2 times 64 radical 2. There are 2 radicals here. So I'm going to multiply those together and get radical 4, which I know is going to be 2, but I'll come back to that. And then 8 times 64 is 512, and then half of that would be 256. Radical 4. Well, radical 4 is 2. So 256 times 2 is 512. No radical here at the end. And that's centimeters squared. Now, I understand that, like I said on the first one, you could have found the area probably quicker using other formulas. I'm going to go ahead and clear everything right now. A square is a rhombus. So I could have actually just said, okay, this is 16 and found that that's also 16 and then just done 16 times 16 divided by 2. Or sorry, 32 times 32 divided by 2, 1/2 d1 d2 from the last lesson. Could have done that. Could have also just found a side length and multiplied it by itself because it's a square. But I want you seeing that 1/2 AP works. And I also want you seeing me using it so that you can use it when you have to use it. And you have to use it on number 3. All right, so it is a regular hexagon. So 1/2 AP. Oops, back that up a little bit. Ahead of myself. So I need the apothem and the perimeter. Nice thing is I gave you the apothem here. It's 10 radical 3. All right. Now I've got to find the perimeter. Well, let's draw that triangle again. I know this is 10 radical 3. I need angles. So it's a hexagon. So 360 divided by 6 gives me 60. The apothem cuts that in half. So this is a 30-degree angle here, which means this is a 60, which means I've got the long leg right now. I need the short leg. I'll call it y again. So the short leg, well, the long leg is equal to the square root of 3 times the short leg. So the long leg is 10 radical 3. This is actually kind of nice here. The radical 3's, when I divide them, are going to cancel out. And the 10 is the y. Again, that's just this. This is 10 right here, which means mg is also 10, which means the side length is 20, which means the perimeter is 20 times 6, or 120. Now I've got everything I need. Now it's just a matter of multiplying. 10 times 120 is 1200. And then just do the half of that. Half of 1200 is 600 radical 3. And that's going to be units squared. Now, one thing I do want you to notice before I finish this video is all 3 of these shapes gave us a special right triangle. The first one was a 30, 60, 90. The square gave us a 45, 45, 90, and the hexagon gives us a 30, 60, 90. There will be times when it doesn't. You could probably take a guess at what lesson 2 or area of regular polygons number 2 is going to be talking about. Stay tuned for that.